Alright, so I'm going to teach you guys a technique of factoring called factoring by grouping. Alright, and it's a technique you haven't seen in Algebra 2. And it's useful when your polynomial is not a degree 2 and when you can't take out a greatest common factor. So you might think at that point, the situation is hopeless, but it's not. So this technique is useful and it'll come up here and there. Just to remember, the importance of factoring a polynomial is to get it in factored form, and when it's in factored form, it's easy to see what the zeros are. And the zeros help us sketch graphs and solve inequalities and equations. So, so this is just like another skill that'll help us do that. So let's go through the thought process that we would take to factor something like this. So when you factor in general, the first thing you want to look at is, can I take out a greatest common factor? In other words, is there a factor in each of these terms that's common that I can take out? Well, this has a 3, that has a 2, that has a 3, that has a 2. So there's no common factor other than 1, so that's not useful. And that has x cubed, x squared, x, that has no x's. So I can't take out a greatest common factor. I can't kind of reverse FOIL, write this as two binomials, because this is a degree 3. And we only do that if we're dealing with a degree 2 polynomial. So, or we often do. So what are we left with? Well, we're gonna look at a technique that's gonna help us to factor this when all those cases sort of don't pan out. Before I do that, I just want to draw your attention to a problem like this. Let's say I've got x squared times y minus y. If I told you to factor this, right? What you'd probably do is look for a greatest common factor and take it out. So, I mean, what's the greatest common factor between these two terms? This is an x squared times a y. That is a y. So they both have y's. So I can take out a y. It's like reverse distributing, and what's left here is an x squared, and what's left here is really a 1. Right? Okay, so that simple example I want you to keep in mind when we go over here. Now, factoring by grouping, as it suggests, means we're going to group terms. So here we're going to group, I'm just going to try something. I'm going to try putting parentheses around these two. And then, yes, this is a subtraction sign, but I'm going to view this as, adding a negative 3x instead of subtracting 3x, because I'm going to put parentheses around these two terms now too.
Good morning. If the fire alarm sounds, please do not leave. They're just testing, and it should not alarm, but if it does, please do not leave the building. They're working on the system. Thank you.
That's an announcement we can ignore. Okay, so the reason this is beneficial is because now if you just look at these first two terms, you can take out a common factor. I've got an x squared that's common to both of them, so I'm going to take out an x squared. And what's left? So again, I'm just focusing on these two. What's left? A 3x plus a 2. And now let's go to this term over here. All right, what can I take out of these two terms? It looks like nothing, but you actually could take out a negative 1, right? This is like a negative 1 times 3, and that's a negative 1 times 2. So if I take out a negative 1, I'm left with a positive 3x plus a 2. Now, I claim this is a good situation to be in. It's a good situation to be in because if you look very carefully at the example over here to the right, I factored x squared times y minus 1 times y. Right, I took out the y. The y, right, in this situation, right, it was being multiplied by the x squared and the negative 1. This 3x plus 2 is like my y. Right? It's as though I distributed the 3x plus 2 to the x squared and to the negative 1. In the same way that if I were to go backwards in this situation, if I want to multiply this out, I'd distribute, and I'd just get back up to here. Right? We're factoring, so we're doing the reverse process. But the point is, this is like my y. This is like the y in the problem to the right, which means I can factor it out the same way I factored it out over here. So I'm going to factor out the 3x plus 2. And what's left? X squared, and minus 1. So look at that again very carefully. It's as though this 3x plus 2 is being viewed as like one entity. It's like y. Right? So now I have that x squared minus 1 times 3x plus 2. And again, like to get back up here, I could view this as one thing and distribute it to the negative 1 and distribute it to the x squared. And you would just be right at this situation again. Okay, we're just using that to our advantage, but going in the reverse. All right, so that is the key step in factoring by grouping. And now you want to look what you got and see if anything else can factor. So that was a good first step. X squared minus 1 can actually factor into x minus 1 times x plus 1. And at that point, we're done. Times 3x plus 2. So now that is completely factored. Which means, of course, if you multiply this all out, you get this original expression, which you may not have, like, who would have thought that this can factor to this? Right? It's a little hard to see, but this factoring by grouping technique sometimes works. So notice it starts by putting parentheses around, sort of grouping two terms and then taking out a greatest common factor. What you hope for is that these guys here are the same. That's important. That's why I had to take out a negative 1 there. Let's do one more really quickly, and this time I'm not really gonna talk much through it. I'm just gonna kind of do it. All right. So factoring by grouping, right? I can't take out a greatest common factor. It's a cubic. So let's try factoring by grouping. Let's see if this works. So I'm gonna take out an x squared. There's an x minus 4 left. I can take out a 3 there. And x minus 4 happens to be left. These guys are the same, which is good. So it's like I distributed x minus 4 to both those terms, so I can take it out. Right? It's like this is like my y. If I distribute it to 3 into the x squared, I get to this, but I'm doing the reverse. I'm taking it out. And x squared plus 3 doesn't factor, and x minus 4 doesn't, so we're done. Okay, so that's a technique that you want to kind of recognize if it shows up.